So you heard Alex give a rather loose account of externalities, what they do to the efficiency of the market, and of the good taxes to correct those inefficiencies. So to recap, an external effect is said to occur if the production or consumption of one agent affects the utility of another agent in an unintended way and when no compensation is made. So an externality is unintended, one or two parties on a third party, and it's not compensated in any way. There's a couple of synonyms there. Some people call these things external effects, some people call them externalities, some people call them external cost or external diseconomy. It just depends on who you read. They're all the same thing, and externalities can be positive or negative. Now, of course, it's not an external cost, but an external benefit, and not an external diseconomy, but an external economy. And they can arise from consumption, they can arise from production, and sometimes they arise from trade as well. If the externality is compensated, if there's corrective action, then we say that the externality has been internalized. These are just definitions, there's no understanding here. So what do externalities do to the market? So the condition for production efficiency, and we can do this with consumption efficiency and with product mix efficiency as well. But the condition for product mix efficiency, for production efficiency, is that the marginal product of making X using L to the marginal product of making X using K should equal the marginal product of making Y using L and Y using K. Right. So this is the condition that we need to meet. Now, this has to be met at the social level. So we can replace this condition by putting an S in front and say, really, we want this to happen at the social level, at the level of society as a whole. That is the condition that we need to meet for the market to be in a social Pareto optimum. But if these marginal social costs consist of two components, namely a component that the private producer faces, as well as a component that is not faced by the producer itself, but rather by society as a whole or some third party, that is an external component in that, then really this is the condition that we need to meet, that PNPLX plus ENPLX, the ratio of that to K, should equal the same thing for the Y's, right? This is the condition that we want to meet, but if we leave the market to its own devices, the producer does not heed the externality, because the externality does not fall on the producer, it falls on somebody else, the market will find this particular condition, which is obviously not the same provided that ENP is not equal to 0. Right? So it is fairly straightforward that as soon as you have externalities, the market will not reach a Pareto optimum. The market will not be efficient. And this has been known since at least Ross. So let's make it a little bit more precise, and let's look at how Teague taxes work exactly. What I'm going to do is actually cut the already simple example down further. So we're making, or we have a company that is making X, and this is the profit that is derived from making X, and there's only one input that goes into that, and that is capital K. So the costs are the price of K times the capital that is used, and then the revenue is how much X you sell, which depends on how much you make using K, and of course the revenue then also depends on the price of X. So this is your revenue, and this is your cost, and then we also make Y, and the only input into Y is labor L. This is the amount of labor, this is the price of labor, so this is your total cost, This is how much you make of product Y, and then this is the price that you sell it for. So this is your total revenue, and then total revenue minus total cost is your profit making Y. And the externality comes in because the production of X depends on the amount of labor that is used in making Y. Now this is a contrived example. The reason that it is like this is just to keep the math as simple as possible while not losing the point. And as I said, it's a contrived example, and really what you need to think about, one way to think about this is that the workers in factory L somehow hinder the use of capital in the production of X. The only example I could think of is that the workers of factory Y, when they go to their factory, cause traffic congestion, and X does actually not use workers, so they must have used driverless cars. So that is the example that we're looking at. The workers in one factory cause congestion that hinders the sale and the transport of the other company, right? It's a contrived example, but it keeps the math as simple as possible. So what would the company that's making X do? We have its profit function. We try to maximize profit, so its marginal profit must be 0, d pi dk, because that is the decision they make, how much k to put in, and then the rest just follows. The pi dk is, this is just linear, so that happens here. So the first partial derivative, dx dk, is this thing here. The pk k dk is of course just pk, so this is the first order condition for the company that makes X. This is the first order condition, same thing for the company that makes Y. And what we have is that it sells things, the sale price of X equals the price of the inputs, in this case there's only one, and the price of capital, and then of course how much you make from that capital at the margin. So this is the marginal revenue, and this is the marginal cost, and these are for the production of Y. So this is what the market would do if we leave them to their own devices. Now, if there were no externality, this would also be the social optimum or the Pareto optimum. But what now if we do a joint optimization, that we actually going to seek the social optimum? We're actually going to maximize the sum of profits X plus Y, which is just pi X plus, no, it is just pi X plus pi Y, but that's not how I've written it down. This is the revenue from X, this is the revenue from Y, this is the cost for making X, and this is the cost for making Y, right? So the pi X plus Y dk, so the first order condition for joint optimization, is dpx dx, nothing changes here, nothing changes. This term does not depend on k, this term does not depend on k, this term depends on k just as like it did before. So on the production of X, nothing changes. This particular equation is identical to this particular equation, right? But things do happen. So at the side of the recipient of the externality, the victim of, in this case, congestion, nothing changes. But things do change on the side of the causer of the externality, of the polluter, or in this case, the congester. This is the congestee, this is the congester. So the pi X plus Y, the L, that is the first partial derivative of the joint profit to the amount of labor we put in. This term depends on linearly on labor, so that goes in there. This term is linear, but this term is not, so we have the first partial derivative of y2l, the marginal product of making y. If you put in more labor, this is revenue, marginal cost, and the additional term that pops up is has three components. This term does not depend on L, so that becomes 0, but this term does depend on L in the following way. This is just the price, right? So this is linear dependence, so that is just the pi. Then the x, the m, how much is the production of x affected by an increase in congestion, times the m, the l. This is the chain rule. How much is congestion m affected by an increase in labor L? That's the margin, right? And this term here, or this expression here, has to equal 0. This is the first order condition for Pareto efficiency. And you immediately see that this is different than it was, right? It used to be pi y, yl minus pi l, and now this particular term has popped up. You immediately see if there's no externality, then the MDL is 0 or the XDM is 0, right? Either the labor in the production of Y does not affect congestion, then there is no problem, or maybe the production of X is not affected by congestion, and then this term becomes 0 and it's gone, and we're back in the same situation. Now this particular term, this particular expression solves as follows, just as we had before, and this particular expression solves like this, where the price at which we sell y is the cost of the labor that we put in, normalized with the production of that at the margin. But what we have to do is take into account that there is an additional cost of this production, namely what is going on in the other factory, in the other good, X. And that is a cost, and therefore it pops up on this side of the equation. So that is the situation that you would want. That is the Pareto optimum. Now, what you can also do is redo the whole thing in sort of a but now with individual optimization, but we introduce a corrective tax, tau L, and we impose that on the amount of labor used. So what happens if we do this? Actually, again, for the company that makes X, nothing has changed. So its first order condition stays the same. For the company that makes Y, things have changed. So its profit is now its revenue minus its costs minus the taxes that it pays, right? So if we take the first partial derivative of the profit to the labor that it's using, this thing is still the same, this thing is still the same as it was, but this term now pops up, and the tau, the L, the tau L, the L equals tau, so we have to subtract the tax, we have to subtract the tax rate, this thing has to equal 0. And the condition for company X is still the same. The condition for company Y has now this tax included as minus tau. The joint optimization had that we wanted this to be like this, so no changes here, and we wanted the we wanted to correct the input prices with this term here, px, xm, ml is what we have here. We have a tau here, so if tau equals this particular expression, then it restores efficiency. And this is known as the Teague tax. An important thing to keep in mind here is that this tau here is any tax. If tau equals exactly this, it's called a Teague tax. And that immediately leads you to a practical problem in setting Teague taxes. In order to restore efficiency, what you need to know is the sale price of X. That is easy, you can look that up. Provided that's homogeneous goods in a perfect market, you can look this up. But what you also need to know is how does the pollution how does the inputs in making Y affect pollution, or in this case congestion. That is what you need to know. And you need to know how that pollution or congestion affects the production of good X. And these two terms are actually hard to estimate. It's easy in theory because you just do the derivations and it just pops up. But this is hard in practice, right? So that is an important thing to keep in mind. So we've now defined the Teague tax as you would find it in a textbook. The tax, and just to recap, the tax that exactly restores the social optimum in case of externalities is known as the Teague tax, named after Teague, who worked on this and published this in 1920. And this is actually what he wrote. If the amount of investment in any industry was carried exactly to the point at which the value of the marginal social net product there is equal to the central value of marginal social net product, the national dividend, so as that industry is concerned, would be maximized. Disregarding the possibility of multiple maximum positions, I propose for convenience to call the investment that would then be made in the industry the ideal investment, and the output that would be obtained the ideal output. With ideally, of course, means Pareto optimum. On the conditions of simple competition, it means perfect competition. If in any industry the value of the marginal social net product of investment is greater than the value of the marginal private net product, this implies that the output obtained is less than the ideal output. If the value of the marginal social net product is less than the value of the marginal private net product, this implies that the output obtained is greater than the ideal output. It follows that on the conditions of simple competition for every industry in which the value of the marginal social net product is greater than that of the marginal private net product, there will be certain rates of bounty. That's an old word for subsidies, the granting of which by the state would modify output in such a way as to make the value of the marginal social net product there more nearly equal to the value of the marginal social net product of resources in general, thus provided that the funds for the bounty can be raised by a mere transfer that does not inflict any indirect injury on production, increasing the size of the national dividend and the sum of the economic welfare. There will be one rate of bounty, the granting of which would have the optimum effect in this respect. In like manner, for every industry in which the value of the marginal social net product is less than that of the marginal private net product, there will be a certain rate of tax, the imposition by which the state would increase the size of the national dividend and increase economic welfare, and one rate of tax which would have the optimum effect in this respect. The students often complain that we do things mathematically. This is how we derive a Teague tax, but I hope that you agree with me that this derivation is actually a bit simpler than reading and rereading and rereading what Teague wrote. This is the original definition. It does exactly the same thing as the math, but the math, I think, is actually more illustrative and better, gets the point across more efficiently. So that is the Teague tax. This is sometimes referred to as the polluter pays principle. That is not entirely correct. It is true that the Teague tax would be imposed on the polluter. In that sense, the polluter pays. But the polluter pays principle means that the polluter pays, whereas the Teague tax means that the polluter pays a very specific amount. Also important to note is that the Teague tax, or a Teague tax, correct things at the margin, at the side of the polluter. And you could argue that the revenue thus raised should be used to compensate the victims of the pollution, but this is actually not included in this story at all. And typically the government takes the revenue of the tax and does something with it that the government likes. And also, if there were compensation paid, actually compensation is paid to the government typically. The compensation is done at a margin. That does not mean that the total damage done goes to zero, or it does not mean that the total damage done is compensated. The compensation is done at the margin. So polluter-based principle and sort of liability for the damage that you cause to others are related to environmental taxes and are related to people taxes, but they're definitely not the same.